All right, thank you very much. Apologies for the issues we had just a while back. Let me just dive straight into the slides and then we'll begin. So I was narrating a story about how that people found out that parents in an area who just had babies needed to have their babies monitored. So they went ahead and purchased this particular baby cam. Unknown to them, there was a manufacturer, according to the movie now, there's a manufacturer. And the movie was done to actually sensitize people against the backdrop of how that people get stuff and use them in their default state. So there was a particular company actually used by threat actors, right, to um, produce cameras, knowing that the demographic of that particular area was largely um, about to give birth or people who had babies. They just went ahead and did some form of targeting of those people, sold those cameras to them, knowing of course they're going to purchase it and all. Now, unknown to them, those cameras were monitored by some gang, and this is what those gangs were doing. They were just um, auctioning babies, right? So every family who bought that camera, they just told them plug and play, just carry it, plug it, and start using it, and they took it out of the box, powered it on, and started using it. And all they needed to use were the features of just monitoring the baby. The technical aspect of it, they were not concerned about it. And these guys were, it was like they traced it up until the end. Of course, it's a movie. So they tracked them, tracked the junkies. They recruited junkies whose job was to break into a house. So even if you caught them, they would say, hey, these guys were perhaps trying to, steal a baby. Normally, they pair people, a couple. But there was a syndicate behind it, which was larger than those junkies whom they sent. The syndicate had monitors in their place, and they had all of those cameras in a place that were monitoring. So people were auctioning babies. The thing that leaked this particular lead, the lead that gave them this access to investigating in this line, was that the woman said, the mother said she kept hearing a sound coming out from the cam, right? Indicating that it was a two-way cam. So they had these cameras viewing the babies, and the babies would make noise and all. And from there, the people say, oh, I like baby number two or baby on camera number two. And then they'll find out the area where that baby is based on, of course, the IPs. And please note, there was free network in those kind of areas as per state-owned internet. So people actually connected to it for free. So it contributed to helping the threat actors take advantage of the default state of all of this. So now that's camera, which is the thing, now being part of a network, having the ability or capacity to allow somebody monitor from somewhere. Of course, most of these IP cameras or perhaps even surveillance cameras have those features, right? Drones, and the rest of them. So having said that, let's dive straight into all of this and see what we're going to achieve today. So we'll be looking at two topic titles, and that is researching attack vectors, sorry, and performing attacks on cloud technology. Then we're going to also look at explaining common attacks and vulnerabilities against specialized systems. Typically, just looking at how that most of our devices today, being part of a network, can actually be subject to a lot of attacks. Now, remember, we're looking at it from the perspective of the pen tester. And you're a pen tester, just assuming the posture of somebody who has the capacity to penetrate a network to see what they can do. So you are doing that to be able to advise the user of the network. So let's look at researching attack vectors and performing attacks. Now, another trend that poses new security challenge is the migration of computing resources into the cloud, right? You have a lot of data and software are now becoming cloud-based, where you don't really need to, occupy space on your device to use a particular resource. Okay, so the cloud represents a network without any physical boundary, or let's say perimeter. There is no border, as it were, the traditional border that we know, which exists, depending on where you are right now. Of course, we are part of a network, but if, example, you're going to extend your network, you'd have to think of the cost of extending that border, which would include certain infrastructure that need to be put in place. Right. So the cloud presents a network without perimeter. There is no border between a traditional internal network and an external user. That is scary, very scary. You can imagine living in a house where your house doesn't have any form of, serious delineation, where you, as in somebody from outside can talk to you on the inside. That's scary. That's creepy. Okay. So if there are users on the external place, right, there will be users on the inside, and those users can access resources that are hosted there. So this lack of perimeter increases reliance on access control, cloud configuration, and network architecture for security. Now, that's a lot put together in that statement. What we're simply saying now the fact that we now have people who could potentially gain access to a network I consider private, there'll be a need to implement some form of control. Otherwise, I'm going to have a lot of issues. Okay. So imagine having a compound where everybody can drive through, right? Or pass through. You can imagine that kind of stuff. So the lack of perimeter increases reliance on access control, cloud configurations, and network architecture for security. In addition, cloud applications and data get exposed to the internet, right? Which means now that you can install an application on your device. And simply because your interaction with that application is not hosted in a place where there's a perimeter or there's some form of delineation, then you may be exposed to people who are on the internet. Now imagine that you have a house and your house is exposed to the busiest part of your city. That suggests that up until maybe 2 a.m., depending on how awake your city is, those people who live in that area can have access to your facility. Now, mobile and IoT devices often communicate with applications that are hosted in the cloud, which is the case today. Okay. So I'm into some form of sporting, and we have this particular application that everybody within our collection of in that community can have access to. We talk there, we schedule exercise points and meet up. Now, there's some information that actually, apart from some recent update that was done on that particular community on the app, you could actually, trace somebody's activity. Now, of course, we don't suspect everybody to be like evil, but what if some very nefarious person gets into that place? There'll be a lot of issues. So the devices that we have, each time somebody installs the app on that particular application, depending on who you choose to become your friend, they get to notice and follow your trend, comment on your stuff, and view the stats of what you've just done, and could maybe advise you, say, hey, you could do this, or this particular place, you didn't do this much. Now that's okay. Imagine that happening to finance. Say we now have finance applications installed on our devices, and because those finance applications or fintech apps or maybe banking apps are installed on our devices, we now have access to people on the internet, right? So all these technologies and architectures increase the attack surface and potentially introduce a plethora of cybersecurity risks, not just a variety. Okay, well, variety as per the varying sizes, different ranges, but then they're actually just way beyond what some people actually have the skill to capture. So cloud computing security includes many of the same functionalities as the traditional IT security. So I was saying this to some people. I had a class, I think was it today or yesterday, regarding security. I see people always wanting to jump into cybersecurity, which is cool. I see people always want to jump into penetration testing, but there is a foundation that everybody requires. You need to know the basics of what makes up a network, because everything we see in cloud or cyber are more or less what was happening here physically before it was transferred. Give an example. For example, today we can actually send money and withdraw money just using bank applications. But you see, that was an improvement on the traditional way of transaction before recently, where you have to walk into a bank, fill a teller. First of all, check your account balance, because back in the day, nobody knew your account balances. It was not sent to you by text, right? You'd have to go into the bank and ask, please, can I see the detail of this particular account? You provide some identification, then they tell you, okay, this is what is in the bank. Then you can now be well informed to know what it is you want to withdraw. But all of those now, you can sit in the comfort of you can wake up in the middle of the night, and with the help of internet or network, you have access to that application. The bankers are at home, they are sleeping. The tellers are home, they're sleeping, but you can actually go ahead and query an automated database, which is just going to respond to you. So there's a need to identify the functionalities that exist in the traditional setting, right? Which include protecting critical information, right? Data exfiltration, deletion, as well as privacy. These are real issues. So even if we move them to the cloud, they're very, very still susceptible to such kind of attack. So there's a document, right, as written by the National Institute of Standard and Technology. It was authored a special publication SP 800-145. It provides a standard, more or less, set of definitions for the different aspects of cloud computing. So remember that our cloud computing, for those who have done it before, is actually these are the three areas. We have what is called infrastructure as a service. This is where you make available physical devices, but people get to access them virtually, right? They have platform as a service where, like what we're using right now, Zoom is a platform. Now we intend to use it for either meeting or for classroom. We don't own Zoom. Somebody owns it. He makes it available for us and we have access to it. Right. Then there's software as a service, which is what most guys are beginning to migrate into. So today, if you buy a device and you want to use Office applications, there are certain vendors that are available. They just get you to, use those applications. You can actually install it on your device or just log into a particular account and use that particular software online, right? So these things are available. Now, these are the most popularly used one. There's quite a lot of these guys that are available today for people to use, right? So infrastructure as a service, platform as a service, software as a service. Let's go on. Now, must have heard about credentials. Credentials are very, very important. We talked, I don't know if we talked about it here, but let's put it this way. Everybody who attempts to use a service online would definitely need to have certain identifiers. And these identifiers are unique to each account. Once you attempt using any of those services, an account is created for you. Those accounts for the purpose of delineating and being able to identify who you are, what you have the privileges to do, right? And for how long you did it for, right? You have to have some credentials allocated to you. An account is created for you and you have them. However, the details with which you log into that account are your credentials, right? Alongside other things. Now, it is very, very important to note that there's a lot of harvesting. People call it mining, data mining, and the rest of that's a popular name for it. But there's a lot of harvesting going on, right? And this is where people, or credential harvesting, this is where people gather and steal valid credentials. These credentials could be usernames, passwords, tokens, personal identification numbers, one-time passwords, and the rest of them. Or any type of credentials that you are going to use to gain access to using any of those services, right? Infrastructure, platform, or software. Right? One of the most common ways that attacker performs credential harvesting is by using phishing. We talked about that, spear phishing, with links that could redirect you to a bogus site. So it's normal. We've talked about it and we know that happens a lot to a lot of people, right? So typically, we have I think we have quite a number of them. Okay, I'll talk about them. I'll talk about, great. Okay, so they're all listed. Great. All right, so let's start. Let's go on with this. So we they are listed. I think about 6 or 7 of them. There's credential harvesting. There's account takeover. There's privilege escalation. There's resource exhaustion, which is more or less denial of service, right? There's side channel attack, and so on, direct origin attack off my head. So we'll look at all of those. So in this particular environment now, this is a lady who's attempting to log into a particular account. So maybe she gets a link sent to her about a publication or a video. And this person who's sending it to her is most likely somebody who constantly sends stuff that are either educative or funny or encouraging to her. She gets it and she goes ahead to click on the link because it bears, a particular extension that suggests that it may be TikTok. Now, unknown to her, it could be a link to some place that is not hers. Maybe she has the application installed or not. Maybe she doesn't. Maybe she doesn't know. Something just jumped into my head. There are some of you who perhaps have applications on your devices that download videos from certain sites. Maybe Facebook downloader, perhaps YouTube downloader, maybe Instagram downloader or TikTok downloader. There's a behavior you may notice with either of them. I don't know which. At some point, it may work after a while. Then at some point, it prompts you to log in to use the application. I don't know if it ever happened to you. The moment you see that, just delete the app and find something else to do. Because it is very likely that the developer of that application is harvesting your credentials. How? Of course, they allow you use it. So there's a level of dependence to the application that you already have. And so the day you want to use it this time, they ask you to log in. And it may look harmless. You just go ahead and log in. If you remember, a great number of us here perhaps even know the details of our socials. We just shall know that his email address, but cannot remember the password. And the beautiful thing today is that you can always reset and nobody will bill you. Okay. So you can click on that particular, in this case of this lady, she clicks on the link and unknown to her, she goes ahead, right, to get a mail, right, indicating that this is a link for her to log in to her um, Twitter account in this particular instance. She shall logs in and she may have some difficulty for it opening, or she may be redirected to the site itself. But at this time, the attacker has harvested it. Okay. So it's usually phishing, right? Spear phishing, where it is targeted at the person and the rest of it. So let's continue. So these steps show how easy it is to perform a social engineering attack and initiate a fake website. In this case, a fake Twitter login site to perform a credential harvesting attack. Step one, you launch set. Remember I said by entering the set toolkit command, then select social engineering attack from the main menu. In the menu that appears, select website attack vectors. In step 4, in the menu, you see that is already explained in the credential harvest attack. Step 5, in the menu that appears next is web template. Use a predefined web template. In this case, is Twitter. In the menu, put an IP address of your site. That's where you want the thing to land. And then step 4, select Twitter. The person gets a mail, right? And the mail gets to the person's email and the mail gets to maybe an email or a text gets to the person and the person sees a link. This is using set. Remember set, the tool that we saw at the beginning. You can redirect users to this fake Twitter site by sending a spear phishing. Okay, so this is not a Twitter handle. Because if you've used Twitter for a while, or X as it were, for a while, you realize that this is not it. So if you go make mistake, click forgot password, you have given them everything with that. So attackers have been known to harvest cloud service provider credentials once they get into their victim system, typically. So different threat actors have extended their credentials harvesting capabilities to target multiple cloud and non-cloud services victims, right? So they just exploit the weakness that are there. What is the weakness in this case? Is actually lack of knowledge, right? Lack of knowledge. And also you may have some form of what's it called now? Some anti-malware installations on your device that can flag a particular link saying the behavior of this particular guy is suspect. Now, let me also say here before we move on that how those applications, why it's good to have an up-to-date application that does most of those surveillance on your devices, because they target signatures and also behavioral patterns. Well, that's actually signatures of those kind of files. There's a particular behavior that a device has that becomes suspect, and we know that it is not a valid one simply because it is having certain behavior side. Okay, so let's dive in straight to look at privilege escalation. Of course, this is very self-explanatory regarding what exactly it does. This time is just looking at, mimicking somebody's privileges and then stealing the privilege. By so doing, allocate those privileges to some other person, right? And the person can go ahead and use the services with your privilege. Now, it is the act of exploiting a bug or design flaw in a software or firmware application to gain access to resources that normally would have been protected from an application or a user. This results in a user gaining additional privileges beyond what the application developer originally intended. So here's how it happens. An attacker takes advantage of these weaknesses or these bugs, as it were, or a design mistake, okay, and goes ahead to access largely operating systems, all right? And typically, it is for the purpose of reading very vital information. What do I mean by that? The original developer of a particular application may not intend for the attacker to gain this level of access. However, you may note that each time applications or services are created, every now and then updates are created. These updates, they are patches, usually to be able to fix certain bugs that they found. And of course, at the time of creation of that particular application, it is not believed that somebody has found a way to go around it, right? So there are certain levels of access that exist, right, for that particular, maybe the developer to be able to gain access and fix one or two things. But because they are not properly handled, right, there's an access that the attacker has to it and influences the validation code of the application, right? So it is usually for certain areas that are considered protected of operating systems or files of softwares. And this is, remember the validation code, this is typically a code that accepts behavior, right, of the nature for that particular application. So once there's a code, right, that indicates that this particular user logging in with this account privileges, this account user that has certain privileges has logged in, the person can have access to, tweaking the application as it were. So normally, there's what is called a bypass. So there's an example. I don't know if you've heard of buffer overflow, right? And this is usually how it works. An application, when you interact with an application, okay, when you use an application, there are interactions that occur between, just like cookies on a website. There are interactions that occur between you using the application and the application. And for the purposes of keeping track of the conversation happening on that application, there is a portion of the application that allows for some level of buffer. The buffer, of course, is keeping conversations until it gets to a certain stage. This is what makes the conversation to be considered valid. Now, typically, every application should have that particular portion, which allows for, in the event that interaction with it, maybe because of network or perhaps speed of your device, it's becoming a little bit slow. There's a need for the application to buffer the conversation going on, so it keeps track of it. It doesn't, not for long. What attackers now do is that they overuse or oversend interactions to that particular application, causing the buffer to overflow. Once the buffer in itself the space allocated to keeping track of the conversation exceeds what it's supposed to keep, that application at that instance would crash. Crashing means it doesn't have any record of the conversations going on anymore. In which case it can be overreading, right? So that's exactly how buffer overflow happens. So they bypass digital rights. Okay, this is how people who those of you who buy devices that they call London use, right? This is how jailbreaking happens. There's jailbreaking for iOS. There's routing for, I think it's routing is called, yeah, routing for Android devices. Okay, so let's jump away from there. So there are two different types of privilege escalations. Number one is vertical privilege escalation. Number two is horizontal privilege escalation. This is what it means. Now, in the vertical privilege escalation, or as it is called, normally you have a lower privilege user, right? And that person's privilege is, how do I put it now, is compromised. And that lower user is given the rights of a higher user, right? So the way this happens, let me give an example. I watch movies a lot regarding IT stuff. This is an old movie. It's called 24. There's a lady that caught my heart in the whole movie. She looked like an underdog, but eventually she became the main guy. Her name is called Chloe. Chloe had this, control where her job was to allocate privilege levels to different people. So they had different levels. There's tier one, maybe tier one, let's go level one, level two, level three, and so on. Where some people have at a certain level, there are some kind of tasks that you're supposed to do. Now, Chloe's job was so sensitive that she had to be very attentive to the task carried out by all these guys. The moment somebody who is at level 2 is performing tasks of somebody who is at a higher level, she knows that that particular person has had their privileges escalated, and the only person who can escalate that privilege is her. So if the person, she didn't give the person that particular escalation privilege, then the person has been compromised. So normally she sacks. She was not a very liked person, if you remember the movie, right? So this is where this is something of that nature, where the privilege escalation, where somebody at lower privilege user accesses functions reserved for higher privilege users. And that's normally tampering with some, interactions on the application or on the user. Okay. So there's a suggestion on how to prevent that. I think it's somewhere in the curriculum. I was reading that earlier. I think it's to um, updates are good. There's also what is called user access control, if I can remember, right? So that's for vertical privilege escalation. Then for horizontal privilege escalation, simply focuses on just like the word horizontal, where a regular user, right, who has access to functions or content that are reserved for normal users, right? A normal user, very normal user, now has been escalated. His privileges have been escalated, right? And the person can have access to content for other normal users. So it could just be spreading the use or spreading the control of one person at a horizontal level, such that the access actually captures that layer. Then there's account takeover, right? Now, the technique in this case, right, is usually this is normally done in cloud environment, right? So what they do is perhaps just gain access. When we say gain access, how do they gain this access? It is usually on account of maybe not so savvy person having these details for themselves. Remember, we mentioned this at the beginning to say that each time you have to interact with an application or a service, and because it's cloud-based, right, there's a tendency for them to, there would be the need for them to create an account for you. That account, of course, has certain credentials. These credentials are what you use to log in. So somebody can actually harvest this information and take over your account, right? So the mechanic here, right? Or let me put this, let's say the mind, right, is to just take over. That's the mind, to take over. So typically what the person does is to how do I take over? That's just what it is. In an account takeover, the threat actor gains access to a user or application account and uses it to then gain access to more accounts and information. So understand this. Taking over a small person's account is not my problem. I want to take over some big fish account or big fishes account. Because as I take that, I'm able to have access to dealing with other people's accounts. So there are a number of ways to detect account takeover. Number one, login location, right? So it is very important, right, to note this. I see sometimes you may get a notification on your email or on your social media account, usually Facebook, right? And the notification either in your mail, depending on how you set up your stuff, it tells you somebody logged into this account from so and so place. Now, in this part of the country, it's poor. If you're looking at login location, you might actually get thrown off because sometimes you can sit you could sit in somewhere like Bauchi and log into your device. Maybe you have a particular account on your phone and you log into a particular, you are supposed to log into that account from your phone, but you couldn't or you didn't, and you log in through to the account on your computer. You would notice a notification sent to you saying that uh, a new login into your account was detected. The person was somewhere in Abuja. Now, you did the login. You are in Bauchi, for example. But because of the exchange points that we have, which handle most of our internet connections, the reportage on where you logged in cannot be very thorough. Until that is sorted, login location may not really help. Okay? But then that's one. This works in places where we have very thorough exchange points that deliver services for certain sales or certain collect. Then there's also failed login attempts. Now, somebody who owns an account will not be attempting too much to log into the account. So the log having a details of somebody who attempted logging in but failed some number of times is a pointer. So most of the setups require that the moment you try, I think as it stands today, the standard is 3 times. Once you log in more than 3 times, the fourth attempt, if you try it again, will lock you off. Typically, what they do is that they'll tell you can't access this account now, give it some time. So if you are not the owner, right, of course, that attempt has been failed. But if you are the owner, you may have patience enough to wait till another time. It even happens on your phones as well. And there's lateral phishing emails, typically sending mails to people within your office environment such that they are not they originate from an account, right? And that account is perhaps, let's say, a colleague having typical address that looks like all your okay. So the person sends an email. Of course, know that that account has been compromised. So it's going to just generally send mails. You notice everybody's getting mail from one particular person. That's a pointer. Number four is malicious authentication or open ID connection, connect connections. Now, an attacker, so if somebody has a question, yes, let me see that. How can one meet account takeover? Oh, great. To mitigate against account takeover, what was that? Okay, of all of this, to mitigate against them is to keep a proper, what's it called? SNMP, Simple Network Management Service that is running. What does that do? It keeps log. Each service that people use, some people actually have what is called Active Portal. Okay, that's one. Active Portal captures whoever just comes into the place. It's not different from what we do when we go into offices, right? So when you get into an office, typically what you do, depending on the kind of environment where you work, you are prompted to, for the purposes of maybe ensuring that everybody comes late. Everybody who comes late is checked. So they have, let's say, what's it called? What they call that thing? Those thumb printers, those um what's in I call them now? What they call those uh, biometric machines, right? So it's someone like that. That's what yeah, biometrics. That's exactly what you do on your network because in biometrics, everybody's we call it footprints, but not be footprints per se. So typically where an application walks past, there are certain digital footprints that are indicated, right, as captured by this simple network management protocol. So you require somebody to set it up. Every form of login, right, that happens on a network would, of course, be recorded. So somebody sits down and logs it. And as always, right, most of these things happen afterwards. Okay. So one of the things you want to do is to ensure that as far as authentication, when people log in, they're authenticated. So as much as possible, ensure that authentication is thorough. Um, educate the staffers to understand that their login details should not be the very regular ones. Okay, some people have a convention. Another way, we do it a lot for WhatsApp, for example, or for most of our phones. Let me use that of your email. Ensure that at every time there is more than one factor authentication, where not just password, maybe a particular code sent to a particular number, because that way you will know if somebody attempts login to your account and you're not the one, you get a notification sending you a mail or sending you some form of detail saying, use this to log in. If you are not the one, report to so and so. Most of these guys do it. Okay. So that's one. That's two. Sorry. One is to monitor by installing, by running SNMP services, right? Simple network management, where you focus on behavioral analysis. You monitor accounts of everybody. Keep logs of those things. Then another way is to just get a team, right? To ensure that as far as credentials are concerned, they should be changed as regular as possible. Now, that's where it's going to be very tough. So these are the ways you can mitigate it, right? Account takeover. Typically, somebody will need to have your details to take over your account, right? So if the person is not having the cool, because, these days, logging into any platform requires some form of authentication on another medium. If you're trying to reset your password, for example, it used to happen those days. Well, if you're resetting the password, once you click reset password, on that same page, they'll ask you put in the old password, put in the new password and all. These days, what they do is they send you a link to a mail. Because there's a mail, they'll ask you to put the mail. That's why it's dangerous, right? Now, there are instances where I can say, click on this, and they'll tell you, put a mail where you want to send the link, right? There are other instances where they'll not even ask you the mail. Your mail is tied to that particular site. And the moment you say reset password, they send the mail to your email address and say somebody attempted resetting your password. If it is you, go ahead. If it wasn't you, report the account. So these are ways to mitigate account takeover. So that way you actually protect against um, what's it called? Um, People being careless with their password. Very importantly, aside all these technical things we just mentioned, which are going to be left for the techies, let the techies themselves do awareness for staffers. It should happen on a regular. And during the awareness, encourage people to actually form a habit of changing their login credentials, particularly email addresses. Sorry, passwords or passphrases, as the case may be. So that's where we can mitigate against them. Is that okay, ma'am? Does that score some points? If it does, then we can move on. All right. Okay. How can we retrieve the account when it's been taken over, especially if the email has been compromised? Okay. So, for email, for example, we advise people to have, of typically, once you are creating an email today, you are expected to have an alternative email. If you don't, then of course that account is gone. But if it's not gone, right, all these private free emails that we have, there's little or much you can, because we're not paying much for it. But if you have, let's say, some enterprise kind of service given to you, that's part of why people actually go for enterprise services. You can actually not petition now, send a query to the service providers to say, hey, I think this account has been compromised. We would actually want to desist having any form of conversation with this going forward. So please do something about it. So typically, what you do to recover it is to primarily um, notify others that, hey, my account has been compromised, so that they don't disease. People do that a lot. Send out a disclaimer. Please stop having conversations with so and so account, and then go ahead and recover the account. So if you suspect something has happened, log in again to another device and say, hey, this account has been logged. They will ask you to fill some information. There used to be secret questions, things like alternative email and the rest of them. Then you can recover that particular email from there. But all these free emails that we have up and down, you go hard. But hey, there's nothing wrong. We can always attempt to do that. Right? So we're good. We can move forward. All right, thank you. So where were we? We're talking about yes, authentications. Yes, before that's malicious authentication. That's original authentication, and then email. So an attacker could typically create how this works. You create a fake application, and please note, um, most of our cybersecurity or most of our IT interactions are still from consumer perspective, where we take tools and use tools. So it is usually, you can imagine a tool causes a problem. Somebody needs a tool to solve it. Until we get to a stage where we can actually create this, because most of this stuff we're talking about that compromise our systems are actually scripts or codes written by people. They sit down, study the structure of the logical flow of this particular application, and then do a counter. So, okay, well, typically what happens is that, once these guys make a request, this is what will be responded. How about we tweak that information to increase how much time it will respond for, or the details it's going to give, or what it's going to ask for, and then include a code that compromises it. And, typically that's what they do. So in the case of the malicious authentication or open ID connect connections, the attacker would perhaps create an application that would require you to have privileges escalated within the application. You're either reading, no, typically write. You can read typically, that's what happens, but writing privileges are given to a particular application or application that handles the authentication, in which case you are prompted to um, they send a mail or send a link where you are able to add a thing or two which compromises that's the code now compromises how the device operates or how the application operates. Then for abnormal file sharing and downloading, it will take a while for us to recover from this one, right? Where typically it happens always. People just download stuff, share files. Please, do you have a flash? Collect and share. It's about the most common ways that people can actually deposit some script or some code on your device, which just compromises your device. And the code could just be waiting for network, right? Because the person who was writing it is sitting at the command and control. He has a script. The moment that device comes up, the code which he writes reports to him, right? And then that's that. So we are now in trouble. So let's look at metadata. Let's look at metadata attack. Now, we must okay, to fully grab this, of course, I believe we know what meta information is. Meta simply is something that's not physically seen with the eyes, or something that cannot be seen with physical eyes, but it's there, right? And this happens a lot to most. A very relatable example is pictures. We take pictures every now and then with our phones. Note that there are certain characteristics that are added, certain details that are added to your pictures that you don't know. But as long as the picture is taken with your phone, except of course you go ahead and discontinue one or two features that are there, your phones, right, depending on how it is, the lower the tech, right, phone, the better. But those very correct high-tech phones include in your picture location, geotagging, right? Where the picture was taken. Have you ever sat down one day and picked your phone and then you notice there's a categorization that happens to your pictures without you really telling it? You notice the picture tells you, oh, this picture was taken in Abuja. You see collection of pictures in Abuja, like, how did the guy take no say you snap picture for Abuja? You didn't sit down. Back in the day, we would sit down, put our pictures together, create folders, and say, Abuja pictures, so and so wedding. But these days, your phone does that by itself. How is that possible? There are certain information that are hidden that are part of those pictures that you take. That's for pictures. So you can imagine WhatsApp text, WhatsApp videos, WhatsApp calls, or just imagine applications, data generated by applications. So traditionally, right, this used to happen back in the day by we doing that naturally. But you notice that what do you call them now? DevOps guys, right? They use some form of information, right, added to a file to indicate where the file should go to for upload. That information is there, but you don't see it. So there's some level of exposure that your application has, right? Especially once you download it, this application that you download on your device, you don't know the scripts that are written somewhere. I have some people who don't use. I was at a meeting with some people, some meeting we had last year in September, and I was pleased to hear this man I respect. I've been in some circles with him for a while, but I don't think he recognized me. And we're trying to create a WhatsApp group to add people into it. And the man says, look, I don't use WhatsApp. And I smiled because I know why. Your WhatsApp as it stands, when you say your chat is end-to-end encrypted, yes, it is encrypted, your chat here. But when your WhatsApp does backup, where does it do backup to? To whom? What are the scripts that are written that are added to your WhatsApp application, as it were, that allows WhatsApp to do backup? But where your WhatsApp they go, where the chats they go. So what most people do now is that this exposure, right, that devices or the applications actually have, right, they are reduced. So when an application requires access to specific assets, it will, not can. Let me put it well. It will query some hidden services to get a set of temporary access credentials. So you have the application installed on your phone. How is it doing update? It's installed on your phone, Sha. There are certain encryption that happens, certain, deletion. We have some applications today that was created by people that can recall a chat that you sent and deleted. So this temporary set of credentials that is normally recalled, which are normally part of that application, as it were, or the particular software, right, can be used to access services. The most common services today that people access, which is very readily available everywhere, is AWS, that's Amazon Web Services. And one of the biggest services that they have is cloud. A matter of fact, most of your movie streaming platforms use AWS. Excuse me, they use what is called storage bucket S3 or a cloud storage bucket. They use buckets for storage. That's the name for the storages. So meta services are some of the most attractive services on AWS for an attacker to access. Why? Your applications or your services have credentials attached to them, which is what is exchanged. Remember I mentioned something about buffer? The part that interacts with the application or the service that is normally kept in the buffer until the conversation is mature are usually the credentials exchange. What are the credentials? Things like the validity of the application, if it is a genuine application, licensed application, the device on which it is working on, and so on. So let me also paint the picture why these meta things are there. You can sit on the system and create a document and save it. Now you've saved it. Where did you save it? It's saved maybe in a document or in a desktop. For some reason, based on the filing system of your computer, it archives it. This file can be found in the computer. In the computer, we have document. In the document, we have this folder. In that folder, we have all of this information out there. But once you open your application, that file that you wrote, you will not see all of these things there. But somebody can actually archive it, or the system archives it, and you can go ahead with the link, which contains information that are not seen with your eye. So attackers take advantage of this. So they know exactly by seeing the conversations happening between an application, right? This is where meta service attack happens. So these meta services are very important. Note, they're important because they allow for conversations to occur between you and the application that you're using. So meta services are some of the most attractive services on, let's put it this way, cloud service providers. Top on the list is AWS. So attackers normally find a way to attack it. If you're able to access the resources, which is those information, then of course you will get a set of valid credentials that can interface with an application programming interface, the API, which is where typically that's where the interaction happens and the buffer is created. So interacting with it, those applications don't know you. What they are looking for are credentials. So any device can interact with that application. Let me paint a picture how that works. You can have a Netflix account on your phone, right? Create the account on your phone. You can now have a credential to log in. Then you're not using your phone today. Tomorrow you sit down on your laptop and you launch Netflix and you are now trying to log in with the credentials that you used to log in on the phone. You know it's going to work, right? So imagine if somebody has hijacked those particular information. Don't you think that the person can actually watch Netflix on any device? Because the Netflix device cannot discriminate to say, hey, this phone, it doesn't belong to Oche. Or the last time we checked, Oche was using this kind of phone, but this phone is logging with its credentials. I'm not obligated to opening this site for it. It doesn't happen. What those applications require is that once you provide certain details which allow for interaction with this application or this service, we are going to go ahead to have a conversation. Somebody has a question. Okay, it's all right. It's okay, Engineer Suleiman. The recording will be available so you can access it. So software developers often include sensitive information in user startup scripts. So you can imagine once we have it, we are good to go, right? So I think there's an application that we can use to be able to, okay. So that's for meta service. Okay, there's an application I can use. I'm trying to remember. Is it an application? I think there's a lab or so for research purposes. Is a tool, um, um, Nimbus Stratus. Okay, that's used to be able to extract certain information that are available, that are meta, that are hidden, that are not seen with the eyes. So let's go straight to attacks against misconfigured assets, particularly cloud assets. There is a service called IAM. I love it. Did some class on it some time back, and we spent a great amount of time discussing it. IAM is identity and access management, which we said earlier at the beginning, at the opening of the class, that now that our devices or services or applications are beginning to interact with things online, there's a need to create some level of access control. It's very important, right? It's like saying that now that people have access to my house, I think it is time to implement some locks and keys so that only people can be around the house, but the people who can go into the house are the people that have the key. Okay. So this is very, very important. But then, as much as this are actually available and also help to protect the systems or the devices, as it were, the assets that we have in the cloud, there's some misconfiguration that can actually lead to attacks, which is usually the case most times. So attackers can leverage any misconfigured cloud asset in a number of ways, right? So we're going to look at these four. I think there are four of them. Yeah, four, and then try to explain them as we press it for time. So remember that IAM or Identity and access management is an implementation that does this. It has to profile users, um, then define them with identities. Each of these identity would have levels of privileges. And those privileges are the things that determine access. So there must be a database, as it were, is actually a database. So what we're saying here is that just like um, any login platform, any platform that requires you to log in, whatever you provide as the credentials would have to be tested against the database that exists for that particular platform or service. Now, once what you impute checks, then of course it will open up, right? So this particular solution is used to be able to administer primarily authentication and authorization. This is saying I've verified that what you provided as credentials for this user is authentic. So it is correct. As per what you provided, we have it. Now let's look at that particular privilege, that particular user. What are the authorization given to this particular person to access? I had an encounter. I had to see a friend some years ago at a military cantonment. And he was in a particular office. So when I went there, introduced myself, he told me what to do, introduced myself, and they asked me if he was expecting me. I said yes. And they placed the call and said, okay, yeah. I'm sure from the conversation, it was his break time, so I could go. So they gave me an ID card. Now, this was when I was way younger. I sure took the ID card and hung it. And I just thought to explore. The man told me, third floor left. So as I said, he pointed and told me to go to third floor left. So for some reason, I shall begin enter different floors. Unknown to me, there were people seated at the various floors who are positioned to, and based on their training, they knew what they were to look out for. I had the card. The card was to be clipped to my chest. I shall held it in my hand. I didn't clip it. So this guy, the way the guy, so I went to a particular, I can't remember which of the floors I went to now, but it wasn't the third floor they asked me to go to. I went to the particular floor. I think I just wanted to walk around. It was one of my first times in a military environment. And I just thought, hey, you know, let's just have some fun. And some guy just stood up at the desk and called me, come here. What are you doing here? I was trying to be smart. The guy looked at me and said, let me see your card. Saw my card. Apparently, they had trainings, and for each level, there was a card that was expected to be there. So their training was to look out for that card. Once somebody was at a level and it's not a personnel, but the person is looking like he's a guest, the person should have that particular identity. The moment the person doesn't have it, the person is illegal. The person should be bounced off. So the guy called me straight and put me, said, look, clip this card on your chest. You are the wrong floor. Go to the third floor. He told me, march here, go up, move here, like this. That's how I moved there. Now, typically, I perhaps was attempting to manipulate the credentials given to me or the privileges assigned to me based on the card given to me. But there was a check at each of those levels. So the authorization have been authenticated, but the authorization I was given for a separate place. I was attempting to explore beyond that. So if an attacker is able to manipulate, right, a cloud-based solution, right, cloud-based identity and access management solution, right, whether it is an infrastructure as a service or platform as a service environment, it could be catastrophic. Now imagine, to join this meeting now, all you need is the link, right? So whoever has this link can join the meeting. But there are places where we can do it. We can actually structure the meeting such that once you are logging in, we send you a code. That itself can also be compromised. But then we can say a code, it can only be used once. Matter of fact, there's a way we can even structure the meeting such that once you enter, you will be in a waiting room. We'll look at the list of the waiting room and say, no, this person is not supposed to be here. The person cannot go in there, right? So it could be catastrophic for cloud consumers if that were to happen. So typically, attackers leveraging on misconfiguration or compromising the configuration can actually lead um, to that being destroyed. Another thing we can look at is fiducial misconfiguration. Now, I'll try to explain what this means is just an identity that is considered valid across many how do I put that, many platforms. Some like single sign-on. I'm not a fan of it. right? And the reason is a point of failure. Because if somebody were to ever have access to that particular detail, that means access to a lot of places are being guaranteed, right? So you're usually, how this works is simply associating an identity, right, across many databases or management systems, right? Which means that all you need is just one identity instead of logging into many things. For those of you who have accounts with maybe Huawei platform, I think Cisco platforms now as well, even AWS platforms. I think they are creating just one account with which you can use to log into whatever. I remember there was a time I was trying to download some stuff from a Cisco site, and I was told that my NetAcad account can actually suffice. So it's beginning to happen, right, in places where we have what's called a federated account or federated or federal federated identity. Now, often application developers may misconfigure the implementation of the underlying protocols. And this in itself could be catastrophic. How do we mean? For example, you could maybe have um, access to, let's say, Cisco NetAccount, like a website, right? Then maybe there's an application like maybe Zoom. Then there is perhaps an application for mobile, right, that you use. And all of this allows you to be able to log into, there's this, what's it called? I've forgotten what it's called. I'll remember. If I don't remember, then it's perhaps not needed. But all this, what's it called now? All of this access that I have, right, are domiciled on all my devices. But then there's just one account that I need, which logs into perhaps, let's say, all of my social media platforms. It's beginning to happen now, such that if you have a Facebook account, you can move from Facebook into what's it called? Instagram. I don't know whether they'll do it now so they can move to WhatsApp. It already is happening. If you make a post on WhatsApp, you can tag somebody on WhatsApp, right? I'm sure they're going to add it much later. If you make a post, you can choose to share it somewhere. You can make a post on Facebook and choose to say, I'm sharing the same post on Instagram. Or make a status update on WhatsApp and choose to say, hey, I want the same thing to appear on either Facebook story or appear on Facebook feed. Because as it stands, those platforms are owned by one person. And for some reason, we're getting to a point where you're going to have just a federated identity. So with that identity, you can log into Instagram, log into Threads, log into Facebook, log into WhatsApp, and other companies that do purchase. So imagine that kind of idea. So that means that if that identity is compromised, all these accounts are crippled. Why do they do it? Well, last, they're trying to just get an identity and identify the various things that are peculiar to you and know what to feed you to do what I believe is called targeted advert. Okay, so that's one way that we can take advantage of misconfigured cloud assets. Okay, let's look at object storage. Typically, um, so we have typically storages are done by saving stuff instead of having a hard drive that you have by your side, have a flash drive. You now have platforms, virtual, that are hosted on some sites, and you have the capacity to store information there. So imagine if there was a configuration that has been compromised or perhaps that is insecure that allows for people to access your storage. Data breach don't happen with that. So let me explain to you the length of it. Say you are in bursary unit and you handle remunerations, and for some reason somebody enters into that record and inserts two or more account details or file numbers. You can imagine what will happen. You can't you cannot explain to us that you are not fraudulent because it was inserted. And for some reason, or they could actually even, inflate certain, you just inflate, add it. I heard of some case that happened sometime. I don't know how genuine it is. That happened in Calabar, a particular parastatal where somebody put his sister as a senior staff and she had retired, but the added hand, she was receiving salaries equivalent of a professor. And it had happened for like 8 months by the time they found out. Now, that is somebody adding it, right? I'm letting you understand that it's very possible that having access to that storage, right, or that particular database could be compromised and somebody can insert anything in there. Could be tax, you know. Anything could be added there. So let's look at the last one here, which is containerization. Now, um, so we have what we call containers. So the containers are give or take, like what's it called? That they are give or take virtual environment where you have the privilege of importing a device into. So sort of like your virtual box, right? There are different implementations. Now, so there are some deployments that actually happened for such kind of places, maybe monitoring devices. So, I was telling us to create a lab and have our own lab, and I'd advise you do that. So you can imagine you don't have the resources to purchase computers and create that kind of lab, but you now go ahead to, get some form of these devices that you have installed, and you are attempting to import certain what's it called, images of some operating systems to create that. And you did that, you mastered it. You now escalate the level to providing such service for someone. Now, this containerization, containerization now allows you to be able to say, you know what, with very little resources, or not little, with minimal resources, you're able to create what they would have spent billions on, right? And you do it. And for some reason, it is not secure. And somebody hijacks it. Could happen for INEC, could happen for IPPIS or GIFMIS, could happen for NYSC Alawi, could happen for anything, right? Can just imagine that those deployments were attacked. Imagine the level of breach that can happen. So there are credentials, of course, that are there that are going to be stolen, right? And you can imagine that with those credentials that are stolen, we may not understand the implication of these things, because a great number of us till today are still, still using the traditional way of, storing files and all. There are parts of the world where there's a company called, is it FastPass or SurePass? I've forgotten what their full name is, but their job was to help people manage passwords, and they were compromised. And you can imagine, okay, imagine something that happened some years ago where they said that some database was compromised, and for some reason, the United States had their CIA, what they call assets exposed. Somebody's asking a question. Let me see the question. Yeah, very ironic. Yeah, very, very. You can imagine having those kinds of databases compromised. There's going, it happened even in this country some time back. This was not even database compromise. This was people placing calls. Okay, well, database was compromised because they have people's phone numbers. For now, we have phone numbers. Imagine if they compromise your BVN, or just imagine they tied your BVN to your salary or to your income account, and they were compromised. Just imagine that. Some form of authentication that can happen that are automated. Imagine taxation, for example. Imagine if the governments of our day just spread around the entire country were to automate tax, apart from the ones that they receive from salary. Say maybe a business owner, and then it's automated such that at the end of a particular month, whether you made the money on, or maybe whatever money was they declared that was made, that was put in the account, a calculation is done and a deduction is made. Imagine if somebody now redirects that deduction where it's going to. If it happen, leave this thing, make people know, help us. You can just wake up one day and realize that a particular country is broke, right? We see it happen in movies, so it sounds like a joke, but it's just simply as long as we depend on technology, there are tendencies that this technology could be compromised and we could have to pay for it. So that's containerization. Containerization is simply the technologies that make it possible for us to, deploy um, uh, computers or devices that are virtual that help us to deliver certain kind of services instead of having them physically deployed. So imagine that they are attacked. Just imagine just imagine that there's some form of weakness or vulnerability. I was given an example the other day about a movie. The movie is called Kandahar. It captures the story that happened about Stuxnet. There's a documentary about Stuxnet. It's called Zero Day Attack. Is it Zero Day? Yeah, Zero Day. Is it 0 day or 0 day attack? Right? It tried to communicate the issue with Iran's nuclear plant and the attempt at exploding it, and how it was foiled, and how that it shot documentary covers the fact that it's some nations that came together till today. Nobody will agree. America say they don't know. Israel say they don't know. Britain say they don't know. Russia say they don't know. China say they don't know. But for some reason, that attempt was made, right? So typically, just imagine that. So let's look at resource exhaustion. That is with respect to what's it called now? Denial of service. We've exhausted this, but I'll attempt to explain from the network perspective, and it's very important why. Everything you know today as network attack started here. What do you mean? This is what I mean. The architecture of the internet was built such that there must be a market, there must be a buyer, or let's put it this way, there must be a device that gives service, there must be a device that requests service. So typically, whether we escalate it from physical to the cloud or wherever, it still follows that there must be a service that we are going to use. The service could be an application. Remember, everything is now as a service, right? As a service, platform as a service, what's it called? Software as a service, infrastructure as a service. Everything is now as a service. So whatever service you want to access, there must be an entry point where you are profiled or profiled and authenticated and granted authorization to use this service. So there must be communication with a server. Now, the moment there is a server, know that that server could be manipulated. How? We explained this before. For a device to initiate communication with a server, there must be some form of initiating conversation, which comes from a client requesting to join. And typically, the request is sent as a synchronization request. The server would have to respond with an acknowledgement to that synchronization and then go ahead to send its own synchronization as a server. Now, this forms the basis of what is called the three-way handshake, right? The fact that any service must be accessed, right? And there's a server giving that service. There are tendencies that is going to be overwhelmed. So this conversation that happens, knowing the attacker, knowing that the server is going to have to respond to any request made, is going to now create scripts or create codes that is going to flood that particular server with requests that overwhelms it. So the architecture, right, allows for you to make a request. One of the benefits of leveraging cloud services is the distributed and resilient architecture that most leading cloud providers offer. This is the reason why today, if you study particularly AWS and observe, or even if you don't study it, the cloud practitioner that is, even if you don't study it and you perhaps even read about it, just read about it, you notice that they tell you that they have robust architectures of devices that fail over, meaning if one attempts to appear like it is being overwhelmed, the services move straight to the next available person. Now imagine that you're watching a movie. Imagine, just look at it, watching a movie on, let's use traditional ones. Let's say GoTV or DSTV. Or let's say you're using one of these trending ones, say maybe DSTV or Hulu or Prime. You're watching a movie on any of those guys. Do you ever ask yourself, why is it such that as I'm watching a movie, some other person is watching it somewhere? And for some reason, I hardly ever get to experience any kind of failure in the communication. Can imagine the level of redundancy that they will have. So for denial of service, right, the way to in case somebody's maybe preparing to ask, or maybe somebody's just attempting to get a clear understanding, denial of service is simply overwhelming the server so that the legitimate service or the service that is meant for legitimate users cannot reach them because somebody has hijacked the service. That's denial of service. And that is done by overwhelming that particular server with synchronization requests such that it leaves too many open sessions and doesn't conclude on them. By so doing, its resources, which is largely processor, is consumed. And then because he crashes. Crashing simply means it lost trail of the conversation or lost track of conversation that makes it a server. So there will need to be some form of clearing for that to happen. So you can imagine if it was flooded for a while, it will lose its concentration for a while until somebody finds out and some clearance is done. There's a beauty to it though. Every traffic that is actually in transition has what is called the time to leave, so it cannot be there forever. So this could happen for, let's say, some few minutes and all. But denial of service just typically refuses or denies legitimate users access to the service. Then distributed denial of service is where somebody distributes this same approach, right? Such that he's not the only one initiating it. He does it such a way that different devices, there's a command and control device somewhere, and it sends scripts to different people who do not even know that they're ones initiating it. So they typically just flood that particular server with a request at a particular time, and then it's overwhelmed. It's still the same thing. It's just that it is distributed with the provision of redundancy for data center architecture. It is easy for this actually to be overwhelmed. So look at this, for example. In this case, network bits per second, this is targeting this particular link. So this to this, of course, this can be overwhelmed. But imagine that we have DNS service, right? And the DNS service is the one who handles how people access this particular guy. It's going to be overwhelming as well. But look at it this way. In the event that we have an array of more than one device or more than one of those, what's it called now? Architecture, where one is a failover, right? Attacks will not really, it's not like it's eliminated, but it's reduced. So this architecture helps to minimize the impact of a DOS or DDoS attack compared to what it would be if you're hosting your application on premise in your own data center. I also believe that this is the way to sell cloud. True, it is a way to sell it, but it scales. You can decide, because cloud architecture can be done private. You can actually own it because AWS is enjoying theirs because they own it, but because they have robust services, they can afford to give people access to their storage as well. So imagine if you own your own, which is where we hope everybody should migrate to, but it might not be that easy because everybody's at different levels of resources as they grow in their businesses. So with a redundant array of resources, you have processing capacity split across more than one device, storage capacity split across more than one device. Typically, if one guy is overwhelmed and the services that is attempting to use is overwhelming it, failover. So you can imagine if we have jam sites in Nigeria to have this kind of service, or INEC sites, or have banking sites, or all of those sites that are owned by, they are domiciled, that are local to us, where we have some form of redundancy. Nigeria can wake up and build a data center, and we can actually even have these failovers happening for most of our services. See, US elections, they did it, they started it the day before, by the next day, then finish. In some countries, they'll be doing it for 1 week, right? Let's get that out of the way. So typically, resources can be consumed, and it leads to exhaustion. Right. So one way to actually mitigate against that is to ensure that there's a redundant array of most of these things that we use. Right? Attackers can launch more strategic DOS attacks against applications hosted in the cloud that could lead to resource exhaustion. Another example of a DOS attack that can affect cloud environment is the direct to origin, what's called D2O. Now, how does it work? The threat actor are able to reveal the origin network or the IP address. So please remember that the services, as it were, the source, right, is known. The destination is also known. But to help the destination, certain services, those services are actually split across, it's like seeding, spread across different devices, and they're able to provide same portion, some form of content delivery network. That's what it is, where they provide some portions of what you're looking for. And so the access that they have to the resources and displaying it is faster than when you have one device who has one processing capacity and one storage capacity, and it's also dealing with other services and all. So just imagine that you have, so let me use the example. Say, imagine that you are cooking food and you are the one person who is cutting onions, frying the meat, doing everything. But imagine how fast that would be as compared to when you have different people. It will cost more, different people doing different things. So you can actually cook food in lesser time. The only thing might be the cooking period, right? Which would have to be the same. But imagine the process leading to cooking it. Or imagine even cloth making, for example. So you have lots of people, somebody's cutting hand, somebody's cutting chest, somebody's cutting the neck, They can do it in less than an hour simply because everybody's there, give them the fabric, everybody cuts their own. Then somebody passes join. This is typically what Chinese people do in their large factories. So it could allow attackers to bypass different anti-DOS mitigations and be able to attack it. Okay. So that way it exhausts the resources that are there. So let's look at cloud malware injection attack. Remember what your malware is. Malware is a malicious software. So in this case, It is typically where the attacker creates a script or an application or a code. Then he goes ahead to inject it into all the platforms that you have. It could be software as a service, platform as a service, or infrastructure as a service, right? So, and by injecting it is simply saying this. Let's understand how injection happens. It understands that there is an interaction between the person requesting the service and the person giving the service. So there are credentials that are exchanged. So his trick is to monitor the conversation, then add in the conversation a particular value that will compromise the conversation or allow a third party to be hearing the conversation. That's how they inject it. So once the malware injection is completed, the malware is executed as though it is a valid instance of request or conversation with the software, with the platform, or the infrastructure. Subsequently, the attacker can leverage on what we call digital footprints or footholds that it has created. Then go ahead and then launch additional attack. So there's a saying, I'm going to say it again. I hope somebody will help me with the Igbo version. The Yoruba version says kokoro tó ń jẹ̀fọ́, ìdí ẹ̀fọ́ ló ń wà. Hausa man says ba a cin gari sai da dan gari. All of this is indicating that usually what compromises a system is not too far from the system. It is usually around there. Okay. So what these attackers do is that they just, it's not too different from how vaccines take care of sicknesses or take care of disease or how disease actually get into someone's body. They always come in friendly ways. For example, if somebody's going to catch a cold, the cold cannot jump and enter the person now. Typically, the person has to inhale some things. The inhalation is a normal behavior of the body. So it's just to say, hey, let's, the best way to, let's get into his nostrils, then into his lungs. And then just stay there for a while. And because we are actually not the original ones who should be there, by the time we stay there after a while, his body begins to feel it, then he's down. And they're like, yeah. In the same way we want to cure it, we pass an antidote or something that cures it into the place. Typically, manipulation, right? So once this is put there, all you need is just one of such scripts or such codes that has been injected. If it stays there after a while, the system or the services or the platform now receive it as a regular instance, and typically it will now spread its foothold and of course lead to other attacks, backdoor attacks, eavesdropping attack, manipulation attack, or better still, data theft. Okay. So side channel attacks are often based on information gained from the implementation of underlying computer systems like cloud environment. So what you do in this instance is just a technology that is implemented. That's why it's called a side channel. I'm trying to use an example now, but it's not a good one. So let me just shut up. Okay. So what happens in this case is there are certain technologies that are implemented, and each of those technology have their own algorithms, which is step-by-step approaches arriving at it. So the attacker's aim is to gather information from those systems or those application or those technology. How he does that, he just observes the system and measures, the system and its hardware. How do they allocate memory spaces? How do they allocate, typically, how do they allocate, how the processing happening? And typically identifies that, okay, even after allocating to all the applications that are running, we still have this amount of application ready. It goes there to just create some allocation again or prompts the CPU to allocate resources to some guy, right? And that leads to a compromise. So most side channel attacks are used to exfiltrate credentials, cryptographic keys, and other sensitive information by measuring coincidental hardware emission. So typically, how fast the processor moves. For the Stuxnet attack, what they observed was simple, that there was a code that normally is, what's it called now? Is it PCI or is it PCI? There's a code that sends signals to the centrifuge, and that signals instructs, which of course informs the centrifuge on how to rotate. If it was rotating 2 revolutions per minute or so, something like that, what they did was just to increase the revolutions. And if you know anything about those centrifuges and how they need to operate, they need to be very regular and consistent. Any alteration could lead to some half-life stuff and explosion. So that's what happened in that case. They just shut that, but before they knew what's happening, it was contained and that. So side channel attacks can be used against VMs and in cloud computing environment where a compromised system controlled by the attacker and target share the same physical hardware. So it's just some technology that is implemented and we can take advantage of the technology to compromise what's happening in the system. Okay. I think that brings us to, let me see, what's the next thing we have? Oh, software development kit. Okay, so this is like a, okay, this is documents such as Swagger and Open API specification documents can help you greatly when you are accessing API implementation. Then you have your software development kits and also CDKs or cloud development kits. These are more or less, excuse me, platforms that indicate or suggest to you or insights into how these applications are supposed to be hosted and the platforms on which they can best perform. Okay. So for the SDK, which is software development kit, is just a collection of resources, right? So with respect to how applications should be, the premise on which applications should be created and where you are going to use the applications, it indicates. It's just like a cookbook, right, for baking different kind of cake. Whereas on the other hand, CDK or cloud development kit helps software developers and cloud consumer deploys application in cloud and use the resources that the cloud providers offer, right? So let's begin to wind down by looking at common attacks and vulnerabilities against specialized systems. In this section, you will learn about a variety of attacks against mobile devices, Internet of Things, data storage systems, the data storage system vulnerabilities affecting virtual machines and containerized applications and their workload. Right? So let's attempt to see what happens here. These are stuff that we've seen before, but we're going to just attempt to look at how they operate. So attackers use various techniques to compromise mobile devices. It's not different from what happens on computers. It still happens on mobile devices. Reverse engineering, right? This is where um, the this is the process of analyzing and the compiled mobile apps so that you can extract information about its source code. And that's why we're always advised to download applications from trusted. I would always say that for the two very popular devices or operating systems that we use, which is iOS and Android, your best choice is to download applications from Play Store because they would have passed Play Protect and have passed how they should be hosted there. Okay, so every attacker, depending on what he's actually looking at, there are quite a large number of them, use any of this. So number one is the reverse engineering. And typically, he sits down and does a collation, right, of every application running on the device once he has access to it, and then identifies the weaknesses that are there, right, the underlying architecture of those applications, and then go ahead and manipulate scripts, right? So if you're going to do any form of update, please make sure you're updating from the stores, please. Okay, don't update via any particular link. You could be using the application and something pops up asking you to use, to perhaps, click on this to do any update. Please go to the application store and do update. Okay, so there's a movie that I watched. I think we talked about, I think we talked before the movie, we talked about did we talk about OWASP? I think we talked about OWASP. Yeah, I think we did. I think we did. I don't know which of the modules we talked about that, right? So it also introduces a like is how do I put it now? Like a step by step what to consider. It's like a framework, right? Regarding how all these attacks can happen. The same to mobile devices. I was trying to talk about the movie. I've forgotten what I was trying to say now. Lost the trail of my thoughts. All right, so the next is sandbox analysis. Sandbox analysis is, you know what a sandbox is? For the benefit of explanation, for the purpose of explanation, sometimes some parents are very scared that their children, every child wants to play with sand, and some parents don't bite. So I'm sure there are some children who don't even know what sand is. When they see it, most kids, once they see sand, they're just excited. They don't even know whether they are from inside a plane or they don't want sand. They just want to straight play with sand. So typically, every child would want to play with sand. I don't know why. There's some feel that they have, playing with sand. But some parents feel like, hey, those sand, since it is actually the child is very delicate, the sand is very maybe loaded with different stuff that we don't know. We don't know who has spat there. We don't know who have, walked there. We don't know what they've put there and all. So what we want to do is to fetch the sand, treat the sand, and put in a box. So the child gets to play with the sand, but the sand is not the sand that has all the potential issues that can cause problem to the child. That's the concept of sandbox, right? So typically what you want to do is to create an environment, right? And matter of fact, it's considered that sandbox is mandatory, right? With respect to access control mechanism. So typically, you take those devices or the apps, as it were, and work on them in a sandbox environment, an environment that's not exposed to potential threat and all. So some of those houses, when you go, you see a very lovely house, but at the corner of the house somewhere, you see a box, right? Depending on how big the child is, the box could be very wide, maybe 2 meters by two, maybe 4 by 4 meters, perhaps could be even 8 meters by 8 meters, depending on how much sand they want the child to play. And then the sand that is there is already treated sand. So you want to have an environment in your lab or on your devices where whatever you are doing, right, to simulate what the attacker could potentially do to mobile device, you want to look at the implementation of a sandbox. And so you go ahead and implement, compromised, doctored compromised applications to see how it will have effect on the application. Okay. So interprocess communication, that's what it's called, where you allow your device to actually interact with applications that were devised for them. So iOS and Android apps are isolated from each other via sandbox environment. Sandbox or sandboxes in mobile devices are mandatory access control mechanism describing the resource that a mobile app can and can't access. An attacker could perform detailed analysis of the sandbox implementation in a mobile device to potentially bypass the access control mechanism. So I can go ahead. Some of those phones that some people get, they call London use or jailbreak or whatever. So I was talking to somebody the other day and realized that sometimes you could have, when you check the specifications of the device that you're using, the storage facility could be, let's say, 128 gig, but what you have available to yourself is just 78 gig, simply because there's a portion of it that's been contained. So they create a sandbox environment. Installation is done in the sandbox environment. So what you are using is actually the sandbox environment, right? So going to the, where are we? Spamming, right? Spam is the, so SMS attacks continue to be some of the most common attacks against mobile devices, right? In such an attack, a user may be presented with links that could redirect to malicious sites to steal sensitive information or install malware. So we know that happening a lot. And the following are some of the most of the prevalent vulnerability affecting mobile devices. Number one, insecure storage, right? So typically, one of the best ways, it's considered best practice actually, is to, as much as possible, um, save very little sensitive information on your device. But people know they agree here. Sure, everything is there. So what we're looking at here is the least you store there, the better. Why? So mobile applications have interactions with your files. Ever attempted using a particular application and then you see some prompt asking you, this device wants to interact with your contact, with your gallery, with your yeah, yeah, yeah. Ever seen that? Okay. So whether it is Android or iOS devices, there's some level of security that is provided. However, those ones, of course, allow, let's say the application, the people who develop the DevOps guys, to be able to use certain, of their scripts, cryptographic scripts, to be able to, prevent some things from happening. So mobile app developers often do not use this secure storage API successfully. An attacker can leverage these vulnerabilities. Like any drug, right? Applications are not too far from them. What I mean by that is this. If you ever try to Google the side effect of Panadol, you will never take it. Matter of fact, sometimes once you buy some drugs, right, and if you are the curious type, maybe you are very studious, and you want to maybe read the manual to be able to tell, the constituents of the drug and the effect of the drug. wallahi, sometimes you may throw away the drug because when they list the implication, tell you drowsiness can happen. Please don't swallow this if you're working on heavy metals and the rest of them. However, there's a percentage of the good that needs to just be there for it to be used. So some of it can be handled is actually collateral damage, as it were, leading to the what's it called? Leading to the well-being of the person who is taking it. In the same way, certain applications cannot be 100% secure, right? So typically, all of these are handled by DevOps. Passcode vulnerabilities are another one. Passcode and biometric integration. In these integrations, um, you could have sensitive information being exposed and full compromise of the mobile device. Certificate pinning is another one. Sometimes your devices actually keep information, things like password. Some sites, for example, the goal of certificate pinning is to reduce the attack surface by removing the trust in external certificate authorities. So every application has to get its certificate of, how do I put it now, of proper behavior or having passed the threshold given to it by a certificate authority, right? So what happens in this case is the fact that at the point of, just like we mentioned earlier about buffer or applications interacting with devices, right? Um, the what the attacker attempts to do is to ensure that every certificate that has been received and been signed, right, is not used anymore. So that from the first day you use a particular application, a certificate is given. It attempts to pin the certificate of that particular application to that particular application so that each time the application will be used, you just refer to an application, the certificate that is there. Whereas it is okay to actually discard applications and use them again or request them again. So the idea here is to actually force the application, right, to the server where the apps are stored, are kept, or where they are created. And typically, those applications, those servers are the ones that interact with certificate authority. Certificate authority grants an application the bill of what do they call them now? The fact that it is now free to be used. Okay. So certificate pinning allows you to, force the application to store the server certificate so that you don't request for it anymore. So the goal is to reduce the attack surface so that you remove any external certificate authority. You use the certificate that was issued before now and then. So that's why it's always every now and then to run updates, to just run an update. Using known vulnerability components, attackers may leverage known vulnerabilities against the underlying mobile operating system or dependencies, right? Things like maybe things like how do I put it now? For Android, there is on my phone, I have two email addresses, and one of the email addresses recently got flagged, and I didn't know why until I searched clearly. There's one Android something application that I don't know, I think I mistakenly deleted. It kept track of the certificate that was issued to that. I'm not supposed to have two email addresses, right? Separate, like if I have an email address, it should be like maybe added to the account that exists already. But because this particular phone I'm using has one phone number and the phone number is actually linked to my Google account, has one email address, I could have only as much as one email address. But I did something, installed one Android Kini. So at the process of actually trying to clear my device, I erased that particular Android. I've forgotten what it's called. And till today, each time my phone boots, it tells me that this particular account is considered invalid. They don't know how it got here. I should go ahead and install the app. And I'm trying to install it now. It did not go install. So these are actually vulnerabilities that are actually there. Now, for the purposes of in most Internet of Things gadgets or devices use Android versions of operating system. Okay, so some of them also may not support your Android versions, and that will lead to a lot of vulnerabilities that could be exploited. Some, especially those that actually use it. Execution of activities using root and other reach and overreach of permission. Application developers must practice and leverage privilege concept. typically what we are discussing here is to say that if you have an application that is installed on a device, right, the application should not be allowed, right, to run in root. Root is more or less like administrator's mode, which is like the super user. Okay, because once an application is running in root, it means that it has the highest level of privileges. So you can imagine if an application like that is compromised, it's going to actually affect the entire registry of the operating system that is stored there. So execution of activities using root and overreach of permission. So the advice says application developers must practice least privilege concept. Then business logic vulnerabilities simply focuses on how the attacker can use legitimate transactions, a conversation that occur between an application, that's the flow that occurs between an application and the person using it in a negative way. That way it creates some form of attack surface. Yeah, that's we I'm going to end now because as it stands, I wanted to show us some applications that can be used. These are like I would advise you download this burp suit. It is a good tool. It looks like what's it called? It looks like Wireshark, right? All of these are applications that can be used to perform security research and be able to test the security posture of a mobile device. Right? We have Postman, EtherCap, and the rest of them. So try to download it. I would advise this burp suit. Very important. Very not very important. Very useful. So as it stands, we have to end because time is over. It's 10 o'clock. It's 3 minutes past 10. As always, the rest of what we have is not plenty anymore. I would let you read them and please ask questions. I'm expecting questions from here, right? Content application, sorry, vulnerabilities related to containerized workloads. Then also from here, how developers actually build their codes, how they deliver them, and how they deploy them, right? Because they're not much anymore, but our time is spent, and I wouldn't want to abuse the privilege given to me to talk to you, right? So thank you all very much for your time with me today. The recording will be made available. I don't know whether the links have started dropping, but I've submitted some of the recordings to them, so they'll make that available to you very shortly, and it'll become reference materials. Thank you all very much. In the absence of any other question, I think it is time for us to go. Thank you, Ebo. Thank you. Thank you, FL Sound. Nice. Thank you. Thank you for the compliment. Thank you, engineer. Thank you. Thank you, Olatunde Lawson. Thank you. Thank you. Thank you. Thank you. Yeah. Thank you, Daniel. Thank you, Umaru. Thank you, Enya. Thank you, Doc. Nagode. Thank you, Mohammed. Thank you. Thank you. Thank you. Thank you, boss man. Nagode.